In your textbook, there's a short section where they talk about the mean as being a balancing point, and they give a visualization of that. I'm going to go over it too, but I'm going to explain why I'm not really comfortable with this visualization. So if I had a small data set like I've got here, I've got 5 different values, and I wanted to find the mean, I would first have to sum up all my values. So if you add these guys up, it's 4 plus 5, that gives me 9, and then 7 is 16, and 8 brings me up to 24, and so then 11 makes it 35. So my mean is going to be the sum of x over n. I have a total of 35, and then n is how much? N is 5. This gives me a mean of 7. Okay, now I've got my mean. The mean is a nice even number. It's 7. Remember that, because that's going to become important in a few minutes, that this is a nice even number. But what I'm going to do now is get into their visualization that they have in the textbook. Now, they don't have the same data set, but this works for our data set as well. I don't have much in the way of frequencies for numbers. It's just going to be a short axis here. I only have one of each one of my numbers. And on the x-axis, though, I have to go from 4 up to 11. Now, I'm not going to start at 0 or 1. I'm just going to put a little break there, and then I'll do 4, 5, 6, 7, 8, 9, 10, 11. So 4, 5, 6, 7, 8, 9, 10, 11. And what I'm going to do is I'm going to represent each one of these as a block on my histogram. So each one of my scores is going to show up as being a block. So there's a frequency of 1 score of 4. So I have 1, 4. I also have 1, 5. So that goes here. And then there's 1, 7. If I had 2 of some score, I would just put a second block up on top here, like if I had 2 5s, but I don't, so I'm not going to do that. And I have 1, 8. And then finally I have an 11, just a single 11. And we have our balance point, as the mean is to be called here. We have our balance point, let me put that in orange, at 7. So the idea is, if this was like what you see in a kid's playground, a seesaw or a teeter-totter, this would balance. Now, that's somewhat handy as a visualization. However, I wouldn't be too worried about having to have a good grasp on this, because ultimately, this sort of visualization isn't going to help you that much going forward. You're never going to hear about this balance point idea again once you leave this chapter. Instead, you're going to be looking at it in a less visualized way and more mathematical way, and that's called a deviation. Now, deviations don't really come up until we start to study variation in the next chapter, but let me just take a moment and show you what the balance point idea eventually leads to. That will be what you're going to need to understand. Let's take a look at our first value here, 4. How far is 4 from the mean? Well, 4 is 3 below the mean. So if I start at my mean and I go back to 4, what I've done is I have gone back 3 on my axis. And so this is 3 below the mean. 5 is 2 below the mean. And so if I start at my mean and I go back to 5, I have gone back 2. 7 is neither above nor below the mean, but 8 is 1 above the mean. So to get from the mean to the 8, I'm going plus 1. And to get to 11, that's 4 above the mean. Now, these are what are called deviations. Don't worry if you don't remember this. You're not going to be tested on this in Chapter 3. Deviations come up with the variability chapter. However, it is useful to look at the mean as being the point at which there is as much deviation below the mean as there is above the mean. In total, my scores 8 and 11, they add up to 5 above the mean. So there is a total there's a total deviation above the mean of 5. Below the mean, there's a total of, again, 5. 7 is right at the mean, so it doesn't change, it doesn't deviate at all from the mean. The reason I wanted to show you deviations is because they truly are the only useful way of dealing with this balance idea. I worked out, remember how I said that the 7 comes out to be a nice easy number to work with? Well, that's because I came up with this data set in order to make sure that there was a nice even number for the mean. That was going to make it easy to draw, and it was going to make it easy to explain what's going on visually. However, when you're dealing with assignments or tests or exams, you're not going to be given easy data sets. Very often, you might get something like this. Let's see, 2, 3, and 5. Okay, so here's a very short data set. It would be easy for me to draw. Again, I don't have much in the way of frequency. I just have one of each score. Let's say that this is 1, 2, 3, 4, 5. And if I wanted to draw this out, it would be, actually, let's put some numbers in here. 1, 2, 3, 4, 5. I have a 2, and I have a 3, and I have a 5. But my mean is not going to sit nicely right on one of these numbers. If I do that, if I work that out, I need to have my sum of x, which is 2 plus 3 makes 5, plus another 5 makes 10. And so my mean over here is going to be 10 over 3 scores. So it's going to be 3.3333 for as many decimal places as you want to take that. Maybe I'll just go with 2 decimal places to keep it simple. So my mean happens right about here. Now that's a bit tricky because where exactly or how exactly did I decide to put it there? Well, I know that when you're drawing on a histogram, the 3 has 2 boundaries. There's the lower limit, the lower real limit, which is a half step below 3, that's 2.5, and it has an upper real limit of 3.5. In fact, that shows me that I put my balance point in the wrong spot. So let me fix that. So this is 3, this is my 4. So my balance point, I'll do it in orange again, my balance point has to be just below 3.5. So the balance point is kind of over here. Now the one thing you really don't need to be doing in statistics when you're trying to do some sort of a proper analysis is to be guessing visually at things. So what I'm doing here by sort of guessing where the balance point is not going to be useful to you in the future. What I'm trying to show you here is that if your data set doesn't work out with nice perfect numbers, like if you get some sort of a decimal or fractional mean, it's not going to be the sort of thing. Finding a balance point on a histogram is not really going to be something that you're going to be doing with your data. It doesn't make much sense. Also, trying to figure out how to draw these sorts of arrows to illustrate what's going on really would be just a real pain in the butt. The one thing, however, that you will be doing going forward in the course is you're going to be working with these deviations. And let's have a look at the deviations, how they would work here. How far is 2 from 3.33? Well, that's not too tricky. The difference between 2 and 3.33 can be determined just by finding the difference, the actual difference between them. So if I did 2 minus 3.33, I would find that 2 is 1.33 below the mean. 3 is 0.33 below the mean. Whereas 5 minus 3.33, that is 1.67 above the mean. My negative here, the total of my negatives, this comes out to negative 1.66. That balances out with the total positive, total positive deviation. Or rather, it almost balances. There's a little bit left over, but that's just because I did some rounding. Remember, I went from 3.33, 33333, and so on. I just chopped that off to 3.33. So that creates a little bit of an issue. I only have negative 1.66 below in my negatives. My total deviation behind the mean is 1.66, where the deviation above is positive 1.67. So it's just a bit of rounding error there. So to recap, having data sets that don't get engineered perfectly to illustrate this idea means you're going to have a hard time understanding or visualizing the balance point. I wouldn't worry about it too much. The balance point is just something that they want to show you because later on in the next chapter, you're going to be learning about deviations. So other than having to maybe answer a multiple choice question in this chapter, where you say that the mean is a balance point, and that means that there is as much value below as there is above. There's as much deviation or difference in scores from the mean below as there is above. Other than that, you can forget about this. We will deal with deviations properly when we get to the chapter on variation. In fact, they're sort of the core of the next chapter.